Hi, my name is Henry Segerman. This is the instruction video for the Extensor Construction Kit by MathMex. MathMex is Robert Fathauer, Sabeta Matsumoto, and me. So I'm going to be going over how to make some of the things you can make with this construction kit. So first of all, the different parts that you get. So there's two different kinds of arm parts. So we call this one the A part and this one the B part. And the reason for this is, well, if you ignore the hole in the middle, the A part has a single hole, just like the capital letter A, whereas the B part has two holes, just like the capital letter B. Then there's the Y part and the X part for obvious reasons. And then we call this the Z part. I guess it looks sort of like a Z if you ignore one of the three plugs. And then there's the spring. So you'll get lots of different parts of different colors. For the purposes of this video, we're going to stick with A parts always being this sort of blue-purple, and the B parts always being this kind of pink. The X and the Y are going to be yellow, and the Z part is going to be green. Let's start by making a Y-extensor. For this, you will need 3 of the A parts, 3 of the B parts, and 2 of the Y parts. And the first thing to do is to put the B parts around one of the Y's. So whenever you plug a Y or an X into either an A or a B, it always goes into the middle hole, and it goes this way around with the sort of two ends of the arms sort of wrapping around the Y. So if you've got it on this way around, then that's not the right way to do it. So let me fix this, just turn it over. So now, then you want to put another one on here, and you have to be a little bit careful to get the ordering right. So does it go on top or does it go below when you plug this in? So if you look from the side, you see all of the A's and B's have this sort of zigzag thing. So there's sort of an upper side over here and a lower side over here. And you want the lower side to be on the bottom. So when this one comes in here, it's going to plug in there. This one, its upper side here is above the lower side here. So this is the right way to do it. Plug it in there. And if you've got it right, then it will sort of lay mostly flat on the table. And if you don't, then it'll be a bit wonky and it won't want to do it. And then let's do this one as well. So again, this one is sort of an upper side of this arm, and this one is a lower side of this arm. So you have to sort of snake it in here so that the uppers and lowers are all in the right order. And then it'll just click on. And again, it'll lay flat if you've done it right. So now we need to get the A parts around a Y, and we need to plug the plugs of the A's into these holes in the B's. So maybe let's just put one of them on here in the same sort of way. And so now we need the plug end of the A to be on the lower side so it can plug into the upper side of this B. Let's just plug this one in here, like so. And then we need to do the other 3 A parts in the same way. And maybe let's, again, making sure that the plug end of the A is on the lower side. Let's plug the Y bit together first, and then you'll need to just sort of bend the plastic in the right way to get the end of the A through the hole in the B. And then here's the last one. Can be a little bit tricky because everything's sort of moving around. But yeah, so there we go. The Y is plugged into the A, and then the last A plug plugs into the last B plug, and here's your Y-extensor. If you want to make a longer Y-extensor, so rather than just 2 stages, maybe you can extend this to 3 or more stages, then you repeat that second step with another Y part and 3 more of the A parts. So maybe I'll do it a slightly different way. So I can plug all of the A parts onto the Y to start with, making sure first that it lies flat, and second that all of the plugs of the A parts are on the same side. Then you can take your existing Y-extensor, and if you line it up, you can see where those plugs have to go in the holes of the end of the Y-extensor that you've already got. And then you can go around and plug them in, like so. And then you've got a length 3 Y-extensor, which works much the same way, except it's longer. It can be a little difficult to remove one of the plugs from the socket once it's in, what you have to do is you have to pinch the two prongs of the split plug together so that the plug can slide out of the cylinder of the socket. So if you have fingernails, then you can just sort of pinch them together with that. If you're having trouble though, a useful trick is to use the cylindrical end of either an A or B piece, and you can sort of push that over the end of the split plug, and of course, since it has the same radius as the other one, then it pinches the two things together. If you replace the Y parts with X parts, then you can make an X-extensor rather than a Y-extensor. And on each level, you're going to need one more of either the B's or the A's. So I'll just make one of these X-extensors. And there's your X-extensor, very similar to the Y-extensor, except that it's got 4 arms on each level instead of 3. With an extensor and a spring, we can make an Extensor Slinger. So the spring goes on the hinge between 2 arms, and it's going to make it sort of jump on its own. So first of all, let's undo one of the hinge connectors, just bend the plastic apart. And then the spring fits over the outer plastic piece, and there's these 2 little hooks, one on either end of the spring, and so this hook hooks underneath the arm, and then we can put, once the spring is around the outer cylinder, we can put the plug through the cylinder. This is still sort of loose, but then what we need to do is we need to hook on the other end of the spring. So this has to go around, this end of the spring has to go around the arm, so you can just sort of push it around and it clicks in. And now it's held in on both sides with the sort of little arm of the spring there and the other one around there. And then this forces it apart. Here's a couple of different ways to use your Extensor Slinger. So find a table and push it down onto the table from 2 different sides with both hands. And if you release both at the same time, it will jump really quite high up into the air. Alternatively, you can hold it closed with the middle finger and thumb of one hand. And this makes it easier to release it all at once, and it also means you can be Spider-Man. Obviously, don't shoot this at somebody's face, including your own face. And be careful when using the springs in general, because they're really quite strong. Let's make a Caltrop. So a Caltrop is made from 4 Y-extensors, which I've already made, and they're connected together using the Z parts. So let me show you how this goes. So each Y-extensor has 3 ends of arms on the sort of inside, and they're going to come together and connect to each other. And they're going to connect, each Y-extensor is connected to each of the other ones at 2 different places, to this pair of arms here, or arm ends here, and this pair of arm ends here. And they're connected together using the Z parts. So let me show you how this goes. So the Z part connects onto the extensor by clipping into the end of the arm, just as it would if this was another A part here. It just clips in through there. And the way that it works is that the plug goes in through the end of the cylinder, which is not where the arm is. So let me show you what not to do. So you don't want to put it in this end. If it looks like this, then this is the one way around. You want it to look like this instead. So let me fix this one here. Oops. And put it in this way around. There we go. And so these are going to fit onto this Y-extensor here at these 2 parts. And so you can just pick them up and get on with it. It's a little tricky because they tend to move around, but it's usually not that hard. And so then these 2 come together here, and again you just plug them together, and then these 2 are connected, and you can see they're starting to interact with each other. And so then we just continue with another Z part on the end of this bottom Y-extensor, and then this one goes say here, click, and here. Hopefully you can see in there. And then there's going to be one that goes on the top. The way that I'm building this, all of the B parts are on the inside, but you could equally put the A parts on the inside. It doesn't really matter. Let me add the fourth Z part in here to connect these two together. Goes there, and this goes there. And then this one goes on top. That's one. And two. And last one. There we go. And then there is your Caltrop, which of course is too big to fit onto the screen at once. It's what happens when you're making expanding toys. You can modify the Caltrop by swapping around the lengths of the four different extensors coming out of this. So for example, you could take the A parts, or the A part of the extensor off of one and add it onto the other to make this one longer. This is one reason to have the B parts on the inside, because then you can easily plug, you can extend the length here by one more A extensor part, whereas if you had a B extensor part, this wouldn't work so well. So you can make a sort of lopsided version. Let's just do one more. So this one makes a cool sort of expanding ray gun. So you can have a compact secret ray gun that will spring into action. If you prefer fantasy to sci-fi, then you can remove the last stage of this extra Y-extensor on the end here and add that onto the long end. And this makes a wand. The wand is sort of interesting. This thing sometimes flips the wrong way out, but you can always fix it easily enough. And if you add a spring onto the handle of the wand, now this becomes a magical wand that will expand from its collapsed state to its full size instantaneously. With two X-extensors and two Z parts, we can make an elbow. So this is very similar to how we made a Caltrop from Y-extensors and Z parts. Again, the extensors get connected together at two places with the Z parts. And there we go. There's our right angle elbow. Unlike the Y-extensor, you get a right angle here. And this lets you sort of grab at things around corners. With more parts, we can make larger structures. So here we're going to use 4 X-extensors and 8 Z parts to make a square. So there's our square, which collapses down into a smaller cross shape and then out into a square. With 6 X-extensors and 8 Z parts, we can make an axis. Now this may look like a cube, but it is in fact a set of axes of space. So maybe your x-axis, your y-axis, and your z-axis, or maybe it is a cube after all. So with 12 of the length 2 X-extensors and 32 of the Z's, we can make a cube. And there we have a nice extensor cube. With 30 length 2 Y-extensors and 80 Z pieces, we can make a dodecahedron. So there's our dodecahedron, which satisfyingly goes between its big and small versions. With the Y-extensors, this doesn't happen with the X-extensors. Hopefully you can see this. Every time you take another step, the angles at which the arms come out flip by 180 degrees. And so that means that in order to get this, this kind of configuration to work for the dodecahedron, you need there to be an even number of stages in each Y-extensor. So you could make this with 4 instead of 2 to make an even bigger one. And I guess the other thing to say about this one is that the angles don't quite work perfectly. The pentagonal angle, the interior angle here is 108, whereas the tetrahedral angle, which is what these things are really doing, is 109.5. 108 is near enough to 109.5 that it's fine, but you may find it difficult to sort of build off this, and apparently that is easier to do if you have length 4 extensors or longer. So we're going to make a chunk of the crystal structure of diamond. We're going to use 12 length 3 Y-extensors and 16 length 2 Y-extensors and 40 of the Z-parks. All right, and it's way too big to fit on screen, but it collapses down very nice and small. And and this one is really nice in that it collapses under its own weight. Just sort of pick it up at the top. Whereas with the dodecahedron, we needed even length regions here to get the angles to work out. Here we need odd length so that so this green, this pink, and this green are in the same plane. I can put that more on line with the camera. So these are all in the same plane here, and in order to get that to work, this has to be an odd length. And this could, of course, extend outwards further. We've just built some amount of it, but there's much more that you could build. So here's the diamond structure again, hopefully just about fitting all of it in frame. And it does this very satisfying self-collapse if you just drop it or pick it up from the top, then it extends or retracts on its own. Just as in Minecraft, you can make larger structures out of cubes. So we're going to make a Tetris piece. So thanks for watching.